it's time for example F. So just a second ago, we did an example, right, where we had $500 compounded quarterly. Now we're going to compound that same amount monthly, still for 2 years. Now what's going to change though is the number of periods per year is different, interest per period, and then number of periods, right? Now we're going to be using this formula right here, right? P1 plus R. Now, again, this time it's franc. Okay, and again, the big difference is this time we're going to be compounding monthly, right? So a problem like this would what we do. Now the first thing we have to do is periods per year. Now monthly means we have how many we've got? Right, we've got 12, right? So N has to equal 12 now. The interest per period, and again, we're going to say this as a decimal. Well, if it's 12% for the year, right? And again, remember, I know this says compounded monthly, but generally speaking, the interest rate always specifies the year unless someone says otherwise. So the compounding is monthly, but it's still 12% considered for the year. So that means each month is 0.01. The number of periods, well, it is 2 years, but there's 12 periods per year. So grand total, we've got 24 periods. Okay, so this is what's important, right? We had to figure out periods per year, and from that, we could figure out how much the interest is per period. The number of periods is 24. Now, this is, the answer would be no different than if you said, hey, I'm going to borrow $500 at 0.01 per year, in other words 1% per year for 24 years. The math is the same as if we said what we said here is 12% monthly, or 12% per year, but compounded monthly over 2 years. The calculation looks the same. Okay, so now let me zoom in. Let's look at that calculation. So I'm going to zoom in down here. Okay. All right, so here we go. Zoom in. And what we ended up with is this. So I have a B equals $500, and then I have 1.01, right, because it's going up 1% every period, 1.01, but I'm doing it for 24 months. So that's to the power of 24. Okay. We grab our calculator. We're going to calculate that out. So I end up with 1.01 to the power of 24. And that's this big old number here. But let's just write it down for reference. I'm going to write it down here so I have room. I've got 500 times, again, big long decimal. We're not going to need all these digits, but I'll just write them down just to be safe. 1.269734649. Okay, big giant number there. And then what's going to happen is I'm going to say times 500, and my answer then will be B equals 634 and 87 cents. Okay, now let's compare that to what we did just a second ago. Okay, now I'm going to zoom out so we can see both together. All right, so the one on the left here is what we did when it was quarterly. The one on the right here is what happens when we compute it monthly. Now it was 633.39. If we compound monthly, we get 634.87, right? So, a little, when 1.03 to the 8th versus 1.01 to the 24th, right? It's similar at the beginning, but right about here, things start to change, right? And we get very different numbers for those decimals. Okay, let's take it to the next step, which is let's see what happens if we compound it daily. Compounding daily. Now, this is going to be kind of interesting, okay? Now, for compounding daily, I already kind of wrote some of this down, right? We're going to assume 365 days per year, and I just kind of rounded this so we're all using the same value for interest per period. Now, interest per period, in other words, it's 0.003287, or if you think about it in percent, that would be 0.03287% per day. So this is as a decimal. Now the number of periods, right, would be n, right, 365 times 2, right? 365 times 2. So then we just double the number of days in a year, and that gives us 730 periods. In other words, if we were doing this manually, we would literally have to do this 730 times to get our final answer. That's where using this formula is much, much better. Okay, so let's now look at this one. And again, what we're going to do is same equation we've been using. B equals, principal is $500, okay, times, now this is where it gets, we have to be very careful how we do this, 1.0003287. It's going to be to the power of 730. 730, okay? Now, let's see what that looks like on our calculator. Right? So let's clear this, right? We've got 1.0003287 to the power of 730. Press Enter, okay? 1.2711 blah, 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 right? Okay? Times 500. And we get a final answer, the balance after 2 years, $635, and again, we're going to round it to a cent, of 57. Okay, now this, right, no way would we want to do that by doing the calculation 730 times, right? We want to just be able to use our cool exponents and do it that way. So again, let's review what happened as we compounded more and more frequently. Okay, so first step, we had 280.51. That was compounding. Nope, sorry, wrong problem. Pretend I didn't do that. Okay, let's come back again. All right, this makes more sense. All right, here we go. We had, if we're compounding quarterly, we got $633.39. Monthly, $634.87. And daily, we got $635.57. All right, couple dollars difference by compounding more and more frequently. All right, well, there you go. And that's our problem for the day.